Hi there. This is 9.2 videos on parabolas. Now we've already done parabolas, but now we've only done vertical parabolas. Now we're going to learn that there's such thing as horizontal parabolas. So we're going to be able to write an equation of parabola in standard form and then graph the equation of a parabola. And there's a couple things slightly different than what we did before in parabolas. Now, let's look at a vocabulary. It kind of all goes together. So what is a parabola? So the formal definition of the parabola is basically can be defined as a set of all points in a plane that are the same distance from a given point called the focus. So here's a vertical parabola that opens up this focus and a given line, the directrix. So these two things are going to be new along with the other word vocabulary, which is our latus rectum. Basically, it's a line segment through the focus that's perpendicular to the axis of symmetry with the endpoints on the parabola. So this whole thing from here to here is a latus recta. Now, we need to learn some basic information. So we've already learned this column. We just didn't know about the focus, the directrix, and the latus rectum. But we knew that if A is positive, it opens up, and if A is negative, it opens down. And you notice we have y equals, and the x is squared. This is the equation, y equals a times x minus h squared plus k. Now, this column over here is new. This is the vertical parabola, opens up or down. This would be the horizontal parabola that opens left or right. Now, if A is positive, it opens to the right. If A is negative, it opens to the left. And now you notice it's x equals, it's no longer y equal. The y is squared. Now, here the axis of symmetry is x equal h. Here, the axis of symmetry is y equals k. Now, notice it's y minus k squared. So, in here, because it's part of the parent function, it opens to the right or left. So, k is, when you pull k out, you have to take its opposite. H is no longer its opposite. Now, these are just formulas that you're going to have to memorize. So, for the focus, for a vertical, it's h comma k plus 1 over 4a. And a gives you a lot of information. For a horizontal, it's h plus 1 over 4a. The directrix, when it's vertical, it's y equals. It's also perpendicular to the axis of symmetry, so it's a horizontal line. K minus 1 over 4a. And over here, it's x equal h minus 1 over 4a. And then the distance, the units of the latus rectum from endpoint to endpoint, is the absolute value of 1 over a for both of these. Okay, so we learned standard form of a parabola. We called it ax squared plus bx plus c equals 0. So it's slightly different here. In this, as a parabola, as a conic, we call our standard form really our vertex form, which we have y equals a times x minus h squared plus k. If it's a vertical, if it's horizontal, this would be our standard form. So when they're talking about standard form in this section, they're referring to what we learned as the vertex form. Again, A tells us, does it open up, down, right, left? Okay, when they talk about general form, they're really talking about what we called before standard form, the y equals ax squared plus bx plus c, or x equal ay squared plus bx or by plus c. Okay. Now, again, we can go from standard form to general form and general form to standard form. So let's look at example 1. So they want us to write this in standard form, because they're saying it's in general form, and identify the vertex axis of symmetry. Well, what we need to do here is we have to complete the square. Remember, we completed the square when we solved an equation, or we try to put it in vertex form. So we have y equals 2x squared minus 12x plus 6. So the first thing we want to do is we want to group this We're going to factor out a 2 and get x squared minus 6x plus 6. Now, 6 is now our b. So negative 6 divided by 2 square is plus 9. Remember in the past when we did this, it's whatever we factored out here, we have to multiply by this, which is 18. The opposite is negative 18, so we have to do it out here so we zero out. So now since we complete the square, we can factor, oh, sorry, this is minus 12. So now it is in vertex form. So they want us to identify the vertex, so h, so it's 3. Remember, vertex is hk, so 3, comma 12. Just like when we were doing all these other graphs, we identify h and k. So a is 2, h is 3, k is negative 12. Okay, our axis of symmetry, because it's a y, it opens up or down, is x equal h. So x equal 3 is my axis of symmetry. And it's going to open up because it's positive. Let's look at example 2. All right, so example 2 says, so here we've got translations. Remember, h and k go right, left, up, down. And dilation is A, and the reflection is also A. So let's look at this equation, y equals negative 3x squared. So we have y equal negative 3x squared, just like in inverse logs and all reciprocal functions. We identify A, and we identify h as 0, and k is 0. So now we know my vertex is 0, comma 0. My axis of symmetry is x equal 0. So let's go ahead and graph. So we know it's 0, 0. We also know it opens down because a is negative. So there's my graph, and I just briefly graphed it. All right. Simple enough. Now let's get to more complicated. So let's look at B. It says y equal negative 3 times x minus 4 squared plus 5. So again, we're going to identify A is negative 3, h is 4, k is 5. So our vertex is going to be what? 4, comma 5. Our axis of symmetry is x equal 4, and we know it opens down, so we can go plot 1, 2, 3, 4, 1, 2, 3, 4, 5 here. And it's going to, of course, I didn't do a really good job here, but that's what it is. All right, so now let's graph an equation that's in general form and identify what the directrix, latus rectum, and the focus are. So let's get example 3a, and you got, 2x minus y squared equal 4y plus 10. So what we notice is our x is to the power of 1, and our y is squared, so therefore it means it's going to open right, left. So let's solve for x. So 2x equal y squared plus 4y plus 10. The book does a little bit different. I'm going to go ahead, I don't like to deal with anything over here, so I'm going to go ahead and divide by 2. I know it's fractions, but that's okay. 1/2 y squared plus 2y plus 10. Okay, so now I have to put it in vertex form, or they call standard form. So I have to group, and then I have to complete the square. So I'm factoring out a 1/2. So y squared, so 1/2 divided 1/2 is 1y. Now remember, this is 2 divided by 1/2, which is the same thing as 2 times 1/2, which equals 1. So plus, or 2 times 1/2 times 2, which is 4. So it's plus 4y plus 10. Now, what is 4 times, remember, sorry. So now I have to take b, 4 divided by 2. and square, which is 4, so plus 4. But I didn't really add 4. I have to multiply this by what I factored out, which is 1/2 times 4 is 2. The opposite of 2 is minus 2, so I have to minus 2, so I can make sure that I get a 0 out on this side. So then I have 1/2 times y plus 2 squared plus I didn't divide this by 2 over here. So this was 5. So this is 5. So this is plus 3. So now I can say A is 1/2, H is -2, K equals 3. So my axis of symmetry is -2, 3. Oh, wait a minute. H is 3 because looky here. This is a sideways parabola. Remember, it's y minus k plus h. So k is -2, h is 3. We have to be careful there, which means our vertex is not this, it's 3, -2 is our vertex. And our axis of symmetry is now y equal -2. It's y equals k. And then our focus, based on the formula, is going to be 3 plus 1 over 4 times a, which is 1/2, which is 2, comma, -2. So this is 3.5, comma, -2. And I'm just using the formula here. And then my directrix is going to be h, which is 3 minus 1 over 4a, or minus 1/2, which equals x equal 2.5. So remember, it's a line. It's going to be a vertical line since it opens sideways. Let's see, we want to know how long our latus rectum is. Our latus rectum, the absolute value of 1 over a, we said a was 1/2, so 1 over 1/2 is simply 2 units. And we take the absolute value, so it's just 2. All right, so now we can go graph this. We know our vertex is what? 1, 2, 3, 1, 2. We know our directrix is x equal 2.5, so it's going to be on this side. I didn't draw very good spacing here. We know our focus is 3.5, -2. And we know it's going to open like this. It's going to open to the right because A is positive. And there is your graph. Okay, so this is my axis of symmetry right here. So we have to identify all these pieces, and then we can graph it. It's really easy. So let's look at B. It's y plus 2x squared plus 32 equals -16x minus 1. So the y is not squared, so we're going to solve for the y. So if I move this over, I get y equals -2x squared minus 16x minus 33. So I've got to complete the square, so I'm going to group first. Minus out, factor out a -2, not minus it out, factoring out, x squared plus 8x minus 33. So now I have B. 8 divided by 2 is 4 squares plus 16. However, 16 times -2 is -32. The opposite is plus 32. So you have to do whatever you factored out times B over 2 squared. Sign included and take the exact opposite is what you add over here. So then I have -2 times x plus 4 squared minus 1. So I can say A is -2, H is -4 because it opens up down, K equals 1. So my vertex is HK, negative 4, comma 1 is my vertex. My axis is x equal negative 4. And what is my focus? Let's just use our formula, which is h negative 4, comma what? K plus 1 over 4a. So k is 1 plus 1 over 4 times negative 2, which this ends up negative 4, comma negative 9 over 8. Oh, this is negative right here. This k is negative 1. Oopsie. Alrighty, so there's our focus. Our directrix is going to be y equal k minus 1 over negative 4, so it's negative 1, minus 1 over 4 times negative 2, which simply becomes y equals negative 7/8. Our latus rectum units is 1 over 4 times a, negative 2, or simply it's 1/2. I did some bad math here. I wrote the formula down wrong. So this is where knowing the formula, it's 1 over a. A is, what is a? We said a was negative 2. Oh, yes. So it's, I'm right. It's 1/8. Negative, or it's the absolute value. So it's 1 over 8 is the distance of the latus rectum, which means it's not very big. So we know it's going to open up down, so we need to go and we need to graph our HK, which is 1, 2, 3, 4, 1. We know it's A is what? Negative, so it's going to open down. What else do we know? Our directrix is what? Y equals negative 7/8. Oh, it can open down. Oh, yes, it can. And this is negative 1, so actually it goes right here. This is why we have to have it correct, and I didn't write it correct. I corrected it later, but I didn't correct here on my vertex. Our directrix, it's y equals negative 7/8, which is about somewhere right here. And our focus is negative 4, negative 9/8, which is about right here. And we know it's going to open down like this, and there you go. Now we've graphed it, and this should just be, if we did this correctly, we could get these points. We could take 7/8 and times 1/2 and move it this direction by that amount and in this direction because it's symmetrical. All right, now let's write equations. So basically it's just formula. We're just adding a directrix, a focus, and the length of the latus rectum. Those are just all formulas, and you plug it in. And the other thing is we now have a horizontal parabola, which opens left-right instead of up-down. All right, so this is write an equation for parabola with the vertexes. So we need vertex is negative 2, comma, negative 4. I'm going to call it directrix. It's y equal 1. So then write the equation graph. Well, for me, it helps if I start to write. So 1, 2, 1, 2, 3, 4. So I know, so we have to use the equation. So if I know my directrix is 1, y equals 1 is a horizontal. That means it has to open up or down. Since my vertex is down here, I know it's going to open down, so I need to use the form a times x minus h squared plus k. So I know h and k, right? hk. And I know my directrix. Now, how do you find the directrix? Directrix is simply going to be what? Go back to your formula chart, and if you look in the book or you look on the video notes, I have it here for you. Whoops, let's find that box right here. So we know it opens up, down. So our directrix, it's y equals k minus 1 over, or k minus 4 over a. So let's go back to that and say k, which is negative 4. So negative 4 minus 1 over 4 times a. I don't know a, but I know that this equals 1. So I can plus 4, so I get 4 equals negative 1 over 4a times a, right, using just simple basic algebra math here. So times a, oh, this is, oh, we plus 4, so this makes this 5. Sorry, we have to add 4 to both sides. Times a, which gives me here, this cancels out. Then I'm going to times 1/5, because since I have a fraction, I don't mess up on my fraction rule. So a equals negative 1/20. So that's all I need for my equation. So half of x equal negative 1 over 20 times x plus 2 square minus 4. So saying this, I'm just going to draw it, and it's going to look something like this. All right, let's try another one with a word problem. And this gets confusing because it's physics, and you know, this is not a physics class, so I don't expect you to know these terminologies, but I expect you to know how to use a regular word problem and how to fill in the pieces. Here, it'll give you a bunch of stuff, physics terms. Okay, so solar energy may be harnessed by using a parabolic mirrors. The mirrors reflect the rays from the sun to the focus of the parabola. The focus of each parabolic mirror at the facility described at the left is 6.25 above the vertex. The latus rectum is 25 feet long. So they're telling us, assume the focus is at the origin. So I'm going to start here, and my focus is here. And they told us what? They told us that it is 6.25 above the vertex. So 1, 2, 3, 4, 5, 6, 7. So right here, it's going to be my vertex. So it's 0, negative 6.25. Since our focus is up here, it has to open up. Remember, the focus is inside the parabola. So if I went down here, it would be outside. So this is one characteristic that they don't really stress, but you should know. So it's going to do something like this. So I know my vertex, so I have 0, negative 6.25. So remember, I'm using this equation, a times x minus h squared plus k, because it opens up or down. Now, if this opened left or right, this would be y minus k plus h. All right, so I know h and k, so all I need is an a, but what else did they give us? They told us that the latus rectum, which is 1 over 4 times, or 1 over a, the absolute value, correct? So I don't know it, but I know it's how many units. They tell me it's 25 feet long. So if I do 1 over a equals 25, put this over 1, do cross multiplication, 25a equal 1, and a equals 1 over 25. So can I write my equation? Yes, because all I needed was an a. I have hk, so it's going to be y equals, or f of x equal, 1 over 25 times x minus 0 square, or just x, minus 6.25. There's your equation, and this is your graph. So we're just basically using what we know and plugging it in and using a formula. So the only thing different here is you have to know the formula for a focus, directrix, and the latus rectum. If you know those formulas, you can, if you got anything, you know that directrix is always outside of the U. All right, focus is always inside of the parabola, inside of the U. And so same thing with sideways. It's going to open sideways. Okay. Focus is still going to be inside. Directrix is now a vertical line instead of a horizontal line because it's perpendicular to the axis of symmetry. Do the word problems, and we will see you in class.